And you can also get storms that last for years. Storms on Earth last for a week or two. Storms on Saturn last for weeks, months, years.
With such an unstable atmosphere, even attempting to enter Saturn's clouds is deadly. As we push out and pass the featureless world of Uranus, we're heading for the very edge of our solar system. And out here, there are challenges that will test human visitors to their limits and beyond. In the future, humankind will journey to distant worlds, searching for new planets we could live on. Next stop, Neptune. At over 3 billion miles from Earth, observing this gas giant is a tough job, so astronomers go high, very high, way above Earth's clouds and pollution to get a clearer view. This is the Keck Observatory, 14,000 feet up on the summit of Mauna Kea in Hawaii. The telescopes here are so powerful, they could see a flickering candle on the surface of the moon. Dr. Heidi Hamel has been researching Neptune for over 20 years. Coming to Keck gives her the chance to study this distant world.
We'd see a beautiful blue planet, but that blue is not water like on our planet. That blue is the atmosphere of hydrogen, a little bit of helium, and most important, a smidge of methane.
Neptune may not have water, but it does have clouds. And these clouds allow Hamel to discover whether humans could survive this alien world. Standing out against the blue atmosphere, the clouds are easy to see. They form when methane freezes in Neptune's super-chilled upper atmosphere. The Keck telescope swings toward Neptune. Hamel takes a series of photographic shots, tracking the white clouds as they move around the upper atmosphere. Measuring the time and distance they move between 2 points, she can calculate just how fast the winds are blowing. The result comes as a shock.
Some of the winds that we've clocked on Neptune do seem to be some of the fastest in the solar system. Some of these little white puffy clouds that we've tracked are really fast. They blow almost as fast at some latitudes as 1,200 miles per hour.
Could we survive such powerful storms? To get an idea of how destructive these winds are, we have to compare them to storms on planet Earth. One of our most devastating winds is a tornado. A supercharged, rotating column of air that forms in the atmosphere and touches ground with catastrophic results. On May 3rd, 1999, at 7:25 p.m., the suburbs of Oklahoma City were hit by a Category 5 twister. It cut through the heart of the area, ripping through property, tossing vehicles like toys, and tearing tarmac from the highway. Scientists recorded wind speeds of 318 miles per hour, the fastest ever witnessed on Earth. On Neptune, it would be nothing more than a light breeze. Clearly, surviving this gas giant's winds would be impossible. But Neptune's ferocious storms could save human lives here on Earth. Studying those violent winds could help us understand our own weather systems better, improving our prediction of the most deadly storms. The reason is Neptune's simplicity. On Earth, the atmosphere, the land, and the oceans all interact. But Neptune has no land or water. Its weather is easier to predict. Huge winds every single day.
The weather on the giant planets is simpler. You've got gas. And that is a simpler thing for a scientist to model in their computer.
Scientists can use Neptune to test weather models for Earth. Computer simulations that mimic how weather systems interact. If they can successfully predict the weather on Neptune, then they're one step closer to accurate forecasts for Earth. But in our quest for another home, one thing is clear: humans could never visit this alien world. Yet there is a near neighbor, a world without storms and with a solid surface. This is Triton, one of Neptune's 13 moons, super chilled and covered in frozen nitrogen snow. It would be big enough for us to live on. The question is, could we? Dr. John Spencer from the Southwest Research Institute in Colorado has been exploring the life-threatening hazards of Triton's icy climate.
The surface of Triton is probably quite bizarre close up. We have frozen carbon dioxide, frozen carbon monoxide, frozen methane on the surface, but also a great deal of frozen nitrogen. It might form snowdrifts and be crunchy underfoot.
Any human exploration of Triton's savage surface is life-threatening. At 390 degrees Fahrenheit below zero, we'll need some special space gear. With assistant Eddie Goldstein, Spencer uses liquid nitrogen to replicate Triton's environment. It allows him to see how materials will behave on this super cool world.
If you were to build a spacesuit that would function at Triton temperatures, you'd need something kind of flexible to make it out of. You might think you might use some kind of rubber material.
At room temperature, rubber is soft and pliable, ideal for creating airtight seals on astronaut life support systems. But drop the temperature to minus 350 degrees Fahrenheit, and it's a different story.
And just because something is flexible on Earth does not mean it is flexible on Triton.
The rubber molecules are flexible at warm temperatures, but drop them into chilled nitrogen, they become rigid as steel. The rubber hardens and shatters like glass.
I will drop it
The
in.
search is on for materials that remain flexible at super low temperatures. Scientists are looking at familiar substances, fabrics that you may be wearing at this very moment. Could nylon be used in the super chilled world of deep space?
And it's interesting because it's just as flexible even after it's cold. And it's not because nylon is anything special, it's because the nylon was woven into tiny threads.
The secret of the nylon's flexibility lies in the weave. The fibers remain pliable because each strand is as thin as a human hair.
So you might be able to make suits out of some material like this if you just treat it in a different way that takes into account this very unusual environment that we have out there.
Even if humans do manage to walk on the surface in high-tech spacesuits, there is one other danger lurking beneath Triton's surface.
What we see is these rather vague streaks, jets of material coming up from the surface.
These dark marks are the clues to Triton's hidden menace. Beneath the frozen surface lie oceans of liquid nitrogen. As the sun warms the moon, the nitrogen turns to gas. This pressurized gas explodes as a